Good evening, everyone. Welcome to Cambridge Guru once again. As you know that we are doing further algebra unit, chapter number 7 of Pure Mathematics 2 and 3, 9709, paper number 32 of A level, Cambridge A level mathematics. So next topic in further algebra, we have already covered in further algebra the general binomial expansion. Next topic in this is partial fractions. So let us start. Sometimes it says that it is easier to deal with 2 or 3 simple separate functions than it is to handle one more complicated one. Meaning, for example, that if it is 1 upon 1 plus 2x into 1 plus x, there are two factors which are in multiplication. So it is difficult to deal with this kind of fraction. So it is easier to write this fraction into two simple linear factors. Linear in the sense that these are of the type 1 plus or ax plus b. Means in the denominator there are two separate linear factors of the type, in this example, 1 plus 2x and 1 plus x. So it is easier to deal with this fraction, with this, you can say, algebraic expression, rather than this. Why we are saying that it is easier? Because since you have separated these two linear factors 1 plus 2x into 1 plus x into addition, now you can either easily integrate this, because the application of this partial fraction you will find in general binomial expansion, because if the your function or the expression is of this kind and you have to expand this, so directly you cannot expand this, you may convert this into partial fraction. And secondly, the application is fine in integrating this complex algebraic expression, right? So you can easily integrate this rather than this function, right? So there are various rules for this partial fraction, and there are various uses also other than this integration and using in general binomial expansion, right? But in your syllabus it is only general binomial expansion, the application, and more you will use this partial fraction in while integrating, right? So it says that this process of taking an expression such as of this type and writing it in the form of 2 upon 1 plus 2x minus 1 upon 1 plus x is called expressing the algebraic fraction in partial fractions. The word partial means you have separated this complete into two parts. One part is of this denominator, which is 1 plus 2x, and another part is of the type 1 plus x, right? So let us discuss type 1. Type 1 of the, you can say, complex algebraic fraction means if the denominator is of the form ax plus b, cx plus d, ex plus f, and so on. Okay, there won't be any algebraic expression which has more than 3 linear factors in the denominator, right? Means in your syllabus question will be asked maximum for these 3 linear factors in the denominator. For example, illustration 6 says that express this as a sum of partial fractions. But before that, there is a condition to use or to convert any algebraic fraction into a simple partial fraction. The condition is that the power of the variable, highest power of the variable, or I would say the degree of the variable in the numerator, that must be less than the degree of the degree of the variable in the denominator, right? So you can write here, if you want, that degree of numerator, that should be always less than degree of denominator. Okay, then only you can apply this partial fraction. So if the case is that degree is not less than degree of the denominator, then what you will do is you will first divide numerator with the denominator and then write the remainder. Or you can just we will take some example, right, how to deal with this situation if the degree of denominator is not less than degree of denominator, right? So in that case we will first divide the numerator with the denominator and then write the fraction. Okay, but firstly we will deal with the simple expression where the degree of numerator is already less than the degree of denominator. So if I say that what will be the degree of numerator in this, you will say that x is degree of x here is 1, degree of s is here is 1, so total degree in the numerator is 2, and in the denominator degree, highest degree, here it is 2, here it is 1, so when this you will multiply with this, 2x cube will be there, so in the denominator degree is 3, so without any division of numerator with the denominator, you can directly use the partial fraction method. Okay, so now how to convert this as a sum of partial fraction? If you look here carefully, type 1, that all these three factors must be linear, okay, in type 1, right? But here you can see that x square minus 1 this is not linear. So first of all, you have to write this x square minus 1 using the formula a square minus b square, which is a plus b into a minus b. So this x square minus 1 you can write as numerator is 5x plus 7 upon 2x plus 1. You can write this x square minus 1 as x plus 1 into x minus 1, okay, using the formula of a square minus b square. Right, now all these three are linear of the type ax plus b, cx plus d, and ex plus f. Now you can use partial fraction. Now what is the method? Method is that basically what you have to write this as equivalent. This three equal signs, this indicates that this is equivalent to whatever I am writing or about to write here, right? So this will always be true. These are used basically for identities. If I say that a square minus b square is equal to a plus b into a minus b, so this is an algebraic identity. So I can use this as these three straight lines, right? This simply indicates that this is an identity. What is the difference between an identity and an equation is that identity is always true for any value of the variable. So if I put a and b, any value I put in place of a and b, this identity will always hold true, whether the numbers are real or imaginary, right? So, but in case of equation, if I say x square minus 1 is equal to 0 for only two values of x which are plus minus 1, this equation is valid, right? So there is a difference between equation and an equality, and an equality is, identity. That identity is always true for any value of the variable, but equation is valid for some values of the variable, right? So this is an identity. I am just rearranging the terms here, right, and writing as a sum of partial fractions, right? So we will use three signs, and how we will use is that I am writing this as some constant a divided by 2x plus 1, because I have to separate these three denominators. These three linear factors are in multiplication in the denominator, so these three have to be separated, right? So one separation is of the type 2x plus 1. I need to find out the value of a, plus b upon next linear factor is x plus 1, and third linear factor is x minus 1. So basically my task here is for what values of a, b, and c I can separate the LHS into RHS. Fine, let me rub this. Okay, now I have to find out the value of a, b, and c. So it is very simple that you pick up this right hand side and take out the LCM of the denominator. LCM will be the multiplication of all these three linear factors. So for a, the multiplication will be x plus 1 into x minus 1, right? Because here 2x plus 1 is already in the denominator, so that won't be multiplied. Plus b will be multiplied by 2x plus 1 into x minus 1, because here the denominator is x plus 1, and here c lastly is 2x plus 1 into x plus 1. Okay, and in denominator will be the multiplication of all these three linear factors into x minus 1, and in LHS we have x into 5x plus 7 upon again the multiplication of all these three factors. Okay, now as you can see that in both LHS and RHS of these identities, denominator is same, so I can easily cut these out. Okay, I can easily cut these out, because here we do not have to find out the value of x. The student get confused that since they take this as an equation. So basically they have to find out the value of x. No, we do not have to find out the value of x, right? Mind it clear. We have to find out the value of a for which LHS and RHS are equal, right? So basically we have to compare the coefficient of x or x square or x cube, whatever are the variables, on both LHS and RHS. We do not have to equate x to something, we just have to compare the coefficient of left hand side and right hand side, because we are writing this in the form of this, right? So if I say that there is an identity, for example, if I say that this is an identity ax plus b and it is equivalent to 5x plus 3. So basically from this, if this has to be equal to this, so I will say that value of a is 5 and b has to be 3 in order for this identity to hold. In order for this identity to hold, x coefficient is here is a, x coefficient in the RHS is 5, so a has to be 5 and constant has to be 3. So basically you have written this ax plus b in the form of 5x plus 3. So a has to be 5 and b has to be 3. So this is what we are doing in this partial fraction. We just are comparing the coefficient of both the LHS and RHS variables, right? So I can cancel these two denominators from the both the sides, and in LHS I have 5x square plus 7x, and RHS we need to separate the coefficient of x square, then x, and then some constants. Okay, so now here this is x square minus 1 basically. So 1x square is here, right? You will write this as ax square minus ax minus a only, because this is x square minus 1. Here you will write as 2bx square minus 2x plus x is minus x, so this is minus bx, and constant term will be minus 1, so this is minus b. Okay, and the coefficient of c, not the coefficient of c, but simplifying this, you will get 2cx square plus 2x, and x is 3x, so plus 3cx, and lastly plus c. Okay, this is just simplifying these two, all the three brackets, right? Now you just combine the coefficient of x square. Okay, so x square, here I have a, this is 2b, and here I have 2c. This comprises x square. Now we have coefficient of x, so writing this as plus x, so I have this plus 3c, and here I have minus b, and lastly combining all the constants which are minus a, minus b, and plus c. So c minus b minus a, right? And in LHS I have 5x square plus 7x. Okay, right? Combining the coefficient of x square, x, and some constants. Now you are in a position to compare the LHS and RHS coefficient. So here coefficient of x square is 5 in LHS, and in RHS it is a plus 2b plus 2c. So now I have an equation that a plus 2b plus 2c has to be equal to 5. This is my equation number 1. Okay. Second is, if I compare the equation or the coefficient of x in LHS, which is 7, and here it is 3c minus b. So second equation will be minus b plus 3c is equal to 7. This is my equation number 2. And lastly, if I compare the coefficient, not the coefficient, if I compare all the constants. So in LHS the constant is 0 because there is no constant that is added. So we'll say it is 0, and in RHS it is c minus b minus a, right? So minus a minus b plus c, this is equal to 0. This is my equation number 3. So far so good, right? Okay, so now we have 3 equations and 3 variables. This can be solved easily, right? Combining, you can combine either equation number 2 and 3 and form another equation, and that put the value of that in equation number 1, right? So find out the value of a, which is 5 minus 2b minus 2c, and put that a in third equation. You will get another equation and then solve B and C. So let us solve this. Okay, let us see how to solve these three equations. Okay, so what I find here is the value of C as A plus B. From equation 3, I find that C is equal to A plus B, right? Put this C back in equation, let us say 1 and 2. Okay, putting this in equation 1 and putting this in equation number 2. Let us see what I get as some another equations. So this equation number 1 now is A plus 2B and C. So twice of C means twice of A plus B. This has to be equal to 5. Simplifying this will give me 3A plus 4B is equal to 5, and then minus B plus 3C means minus B plus 3 of C means 3A plus 3B. This has to be equal to 7. Simplifying this will give me 3A plus 2B is equal to 7. Okay, so now this is my equation number 4. This is equation number 5. Subtracting 5 from 4, I will get 2B is equal to minus 2. That means value of B is minus 1. Okay, if value of B is minus 1, putting this is in equation 4 or 5, I will get a value of A as 3A is equal to 5 minus 4B. So value of A I am getting is, I think, 3. Okay, this is 9 minus 4 is 5. Yes, value of A is 3, value of B is minus 1. So value of C is A plus B. That means C is 2. Okay, so these are the three values that I am getting. Right. So my partial fractions are now that my complex term, which was, I think, 5x. Let me see. It is, yes, x into 5x plus 7. So x into 5x plus 7 upon 2x plus 1 into x square minus 1, that has been converted into value of 3. A is 3, so it is 3 by 2x plus 1. B is minus 1, so minus 1 upon x plus 1, and C is 2, so this is 2 upon x minus 1. So that's how you have converted this complex algebraic fraction into 3 simple sum of partial fractions. Okay, so just go through this video again by pausing and just go through the process, that what all the steps are involved in this long you can say question. Okay, let me give you another question for this in this very video, because in the next video I will try to come up with type 2, because there are 3 types that you will learn in partial fractions, or 3 types of denominators that you need to convert. Okay, so let us quickly solve another problem, which is that express this as sum of partial fraction. As you can see here, that there is a slight modification in this. Modification is that the degree of numerator is 2 and denominator is 2. Okay, so I told you at the start of this that the condition is the degree of numerator should be less than denominator. So first of all, we have to divide 6 minus x square by 4 minus x square. Okay, so 4 minus x square, 6 minus x square, you will divide this by 1. Okay, because if you multiply this by x or some x square, you will get a higher coefficient of x, a higher degree of x square, right? You need a degree of x square as x square. You need a degree of x as 2. So here the divisor degree is 2, quotient degree is 2, so you will get only 1 as the quotient, right? So this is 4 minus x square if you multiply this. Now, as a simple process of division that we have already done in dividing polynomials, chapter number 1, just go through those videos. You will come to know that how we will divide these two polynomials, right? So sign will get reversed. So the remainder you will obtain is 2. So basically what you have done here is, look at this very carefully, that 6 minus x square was your dividend. You have expressed this as multiplication of this divisor with the quotient, which is 1, plus there is a remainder 2. And initially the question was 6 minus x square upon 4 minus x square. So basically if you divide this whole equation by 4 minus x square, so this original question you have written like 1 plus 2 upon 4 minus x square. Fine. So instead of expressing this or writing this or dealing with this 6 minus x square, we will deal with 1 plus 2 upon 4 minus x square. So instead of writing this as a sum of partial fraction, we will write this as a sum of partial fraction. Okay, 1 will remain 1. So basically we have to pick up this 2 by 4 minus x square. Now write this as 2 by 2 minus x plus, not 2 by, some a, because you have to find out the value of a, right? A by 2 minus x plus b by 2 plus x. By 2 minus x plus x, because 4 minus x square is a square minus b square. So this is basically 2 upon 2 square minus x square, means 2 upon 2 minus x into 2 plus x, using the formula of a square minus b square. Okay, these formulas, a plus b whole square, a minus b whole square, and a square minus b square, all these formulas must be on your tips. Okay, now I can directly find out the value of a and b because I know the shortcut method that I will give you some other day, because you do not have to use shortcut method. Okay, you will use the same procedure that we have already done in the previous question, that you will take the LCM, then compare the coefficient of a and b, or coefficient of x and x square from both the sides, right? If there are no coefficient of x square on LHS, put it equal to 0. Similarly, if there are no coefficient for x, put it equal to 0, and if there is only a constant, just put the coefficient of constant here and constant here equal. Okay, so I'm writing directly this is equal to, if it is 2, then I will write as this is 2 upon 2 minus x, so it will be half upon 2 minus x, and if it is minus 2, so I will write this as again half 2 plus x. You can simplify this. Okay, this is 2 plus x plus 2 minus x, that will be 4 upon 2 minus x, and 4 divided by 2 is 2, so you will get 2 upon 2 plus x and 2 minus x. Perfect, right? So this is how you can separate this to the algebraic fraction into sum of two partial fraction. One is 1 upon 2 2 minus x, second is 1 upon 2 2 plus x. Okay, if you have any problem in any part of the partial fraction or any part of the unit that we have already covered, please mention in the comment. Mention how you like this video in the comment, or you want any specific topic to be covered. Just type it in the comment and I will try to make some video on it. Okay, and I will also explain how I have arrived at this shortcut method for type 1. Okay, I hope you enjoyed the video. See you soon. Till then, take care. Bye bye.